Alright everyone, good day. I'm just going to run over some of the new features in the new BlendME add-on for Blender 2.57 stable. Now that Blender's stable, I've got a link to the desktop, and I open up the new Blender. The first thing you'll notice with the add-on that's changed is that BlendME is now located in the System menu, and you activate that add-on and it creates the architecture menu here on the left, and here you can start up all the relevant sub-modules. Okay, so you start up each sub-module separately. So if you're doing only CFD, then you only start the CFD module. If you're doing only energy, you start up only the energy plus. Similarly with life cycle, radiance, and sun. You can start up multiple modules as well. So I'm going to start up the radiance and the sun module that we're going to be using in this tutorial. What's that done? Well, it's created these sun path and radiance modules in the scene menu. And also elsewhere throughout Blender, it's added various menus so that you can interact with Radiance and do sun path calculations. Now what I'm going to do for this quick tutorial here is simply create a zone. We'll make it 2.8 tall and 6 wide and 6 high. Okay, 6 meters that is. On the northern side, I'm just going to put a window. So the way that I'll do that is just delete only the faces. Select the edges, scale them out, and what I want to just do is just make, if I scale in the Z direction, I'll just make a thin window just so that we get some nice effects inside. So there we go, a bit like that. Fill that up with a face now, make that face a separate object. Now I've got a window here. I can call that object window if I like, and I can call the other object walls. There we go, walls, there we are. So if I go back to the window now, I need to apply different material to the window. So I can get that and I'll call that material window. I'll make it a slightly bluish tinge, let's say, just slightly. There we go. And just for looks inside of Blender so that we can keep track of what's windows and what's not, we'll set the alpha down for that. But the more important thing is that in the Radiance menu you actually set it to be a window. Okay. Now you still can't see it as transparent here in Blender, so I have to go to the object menu and turn on transparency for that particular window object. So there we are. So now I've got my simple scene. Now what I want to do is calculate the sun path over that. So I'll delete that object there, delete the default lamp, I'll add a sun, go into the sun path module, leave everything else as a default, and we'll apply the sun path. If I now go back here to the frames and click left and right, I can take the current local time over here, and I'll set it to 8 o'clock in the morning, let's say. So we're in the southern hemisphere here with the latitude and longitude. This is Perth. So you can see the sun actually rises more in the southwest in the summertime. It's 6 months away from the northern hemisphere. So it comes up and over to the north and then down to the southwest. So I'll take it back to 8 o'clock in the morning. Now what we want to do in this new I'll view from the camera, and in the new BlendME module, the Radiance module, we have support now for multiple cameras, which is a really cool thing. So what you can do is if you want to do multiple perspective renders inside of the scene to assess glare or whatever it might be, then you just set up all your cameras and then you just click the button and it'll render all of those various settings. Okay, so now we'll view it, put this camera just inside just to get some sort of internal render, but all I'll view is that box there, which isn't very interesting at the moment. Normally for internal scenes you want to go to the camera and set a wide angle lens of about 90 degrees. There we go. Now what we'll do is we'll be rendering this here. I might even fly in just to make it, there we are. Okay, so that should give us something a bit more interesting. We'll see a bit more of the scene. If I go back out now, like I said, we can have multiple cameras, so all you do is just add another camera. I'll set this one to be outside. I'll move it along the y-axis. And if I view the active object as a camera and just fly around just to get a nice, kind of a nice view. There we are. Let's view it from around about there. Okay, so that'll be an external view. I can change this to an outside camera, and I could have selected the other camera inside and called it inside. There we go. Okay, so now we've got our scene set up and everything's ready to go. What we'll do is I'll just select everything inside the scene. What I'll do is I'll go back to the Radiance menu and we'll plot this, we'll render this as an intermediate sky with the sun. Okay, and I'll save that as something on the desktop. We'll call it Radiance.blend. Okay. So now everything's set up to ready to go. We have to just write the case files. And if you look in the terminal window, you should see that it's created all of the relevant case files for Radiance. And now it's all set up, we should be able to render the current scene. And what that's doing now is making the system calls to Radiance to render those various images, okay, for the two cameras. Now the thing is, for each camera, if I look here, you can render Radiance or Radiance values, or. Okay, in this case we're rendering both Radiance and Irradiance values for both the cameras. For the 1st of January at 8 o'clock in the morning, an intermediate sky with sun. Okay. Now another thing that's common to do in the building industry is to actually work out the daylight factor on a working plane. We don't just want to do perspective renders all the time because they're not very scientific. So we'll put this working plane here, we'll add a new plane, and we'll set it to the same size as the room so it fits tightly within the zone. So there we are. Now we've got a working plane inside of the zone. And what I can do is I can go to the daylight factor menu, and I can again I can write the case files for the scene, but I don't need to because I've already written them once for when we're doing these perspective renders. I can also generate the octree, but again we don't need to do that because doing the perspective renders it made the octree for Radiance, so that they already exist in the Radiance case folder for this particular time of day. So all I have to do now is change the settings for the resolution and the accuracy. The accuracy will greatly affect the calculation time. So I've selected the working plane only because I don't want to output it on any other objects, and I can click calculate there. And this will now calculate the irradiance values on that working plane, and you can see the calculation didn't take long because my accuracy was quite poor. Okay. Now here's the really neat feature of Blender. Blender has native capability to handle high dynamic range images, which is very, very nice. So what I can do is go into UV image editor mode, and I can open up those images that we just created. So this one here is going to be our internal render. There it is. Now that's the actual radiance values. I can also open up the irradiance. Whoops, that's the outside image, sorry. The irradiance here, it's got the irrad prefix. So there we are. So now inside of here, and you can actually pack these images now into Blender, and that's an emailable form that you can just send off to anyone, which is really nice. So you've got your internal radiance, external radiance image. It hasn't been exposed very nicely, but there we are. And now we've got our internal irradiance. Now what we can also do is, with the BlendME add-on, we've actually ported a lot of the common operations you do with Radiance in and added these as panels in the image operations. And what we would often want to do is add false colors and thresholds. So false color, if we take this image that we have here, you'll often want to do a false color just the same as Radiance's native false color. We apply a multiplier of 179 to get lux values. We're going to label it as lux. Okay. We could press the get daylight factor to get the multiplier for a daylight factor. We'll set the scale to 0 to use an automatic scale, and we'll output this as internal lux. There we go. And if I click make, that now should make the internal lux levels for this image. It's quite nice. Similarly, so you can do that with any image. Now if we open up though our working plane, there's our working plane image that we took for the trace across the working plane. What we often want to do with an image like this is threshold it and work out what percentage of the area is below a certain lux level. So in this case we'll set a limit of 300 lux, we use the same multiplier because we want to get lux levels, and the output that we'll use, we'll call it Radiance threshold. There we go. And the exposure is just for outputting the visuals. It doesn't actually change the result. It simply makes the result look nice. And if we calculate that across here, you can see that our threshold percentage is 62.1%. Okay, that's the amount of this area that is below 300 lux. Okay, but here's the really cool thing. So that's using some of calls to Radiance, but Blender actually has some really nice native capabilities inside of it for handling high dynamic range images. So we'll have a quick look over those right now. If we go into the node editor, we can add these nodes here. We'll get rid of the default ones, and what we can do is we can process an image similar to this using only native internal node editors. So we'll add an input node and it'll be an image. Okay. One of the things that we'll actually need to do that we haven't considered just yet is if we take this original trace here, this image has been exposed, so that image that we're seeing here doesn't actually show the original values that were calculated by Radiance. They're exposed to a value of -4. So what we might want to do here is actually set the limit to about 0, set the exposure to 1, and we'll output an image called original. These will output now the original values. Because we've got a threshold limit of 0, it will output all of the values and it'll expose them to a value of 1, which will be the default multiplier of 1. Okay, so if we calculate that, you can see now we've got our unexposed image. The threshold percentage is 0, so we haven't cropped any pixels out, and it's a much brighter image. We can now open that image in our node editor. Open up the originals. There we go. And what we can do now is apply math operations to threshold it natively inside of Blender, which is a really nice feature of Blender. So what we'll first of all want to do is to multiply it by a value of 179 to get lux. Okay, that is the efficacy, luminous efficacy. And we'll add another value here that will actually apply the greater than threshold, and we'll make it 300. So it was the same as the one that we used before to actually get this image. There we are, we've still got it saved there. Now we'll add another math operator. If I just get rid of that, and I've got to get rid of that and connect the image up to there, and I'll connect the image up to this one and that one, and this will multiply those results together to actually, this will take the output, which is 1s and 0s of the thresholded image, and multiply it with the original image, so that we should get outputs that are like that, with the unthresholded part shown like this. The last thing we want to do is actually apply a exposure to the thresholded image that we got, and that'll be a multiplication factor on the output here, and we applied an exposure of -4 previously to get this image. So -4 means 2 to the power of -4, which is about 0.06, let's say. Finally, we'll add an output, and we'll output it to the viewer. There we are. Now if we go to viewer node, you can see we've got our thresholded image that was created natively inside of Blender. It's very, very similar to the one that we created in Radiance. The only differences, small differences, are because of rounding error and some interpolation used in Blender's image processing. The cool thing about doing it in Blender, though, is that now what we can do is this here is our threshold value, and we can actually just drag that around and interactively change the processing of the image. So we can actually change the threshold value and see that. Now the output here is grayscale. The only reason is because of the multiplication. We dealt with absolute values, so we lost our RGB color information. But we can get that back if we used more filters back at the beginning. We could actually get the RGB values back into the output. You can add, separate RGBA and combine RGBA out. Okay. So that's just a quick overview of Blender's native image processing capabilities for high dynamic range images, and the BlendME add-on with Radiance capabilities, vastly improved Radiance module. Thanks very much for listening.